Hey everybody, welcome to another Cloud Lunch and Learn session. We'll give it a little minute until people join. This is where I check that I scheduled the social media posts, but I am sure that we did. We use a tool called Hootsuite, and actually it's been really great. You can schedule up to 30 posts for free, and it's been brilliant. The other day I logged on and they said, hey, we're closing this down. You can get five scheduled posts, and you have to sign up to pay us. And I was like, oh dear, that's not great. So yeah, we've been trying to do it a bit of a different way. Hi guys who've joined. Welcome to another Cloud Lunch and Learn session, the second in our GitHub series with Ishan and John. Let us know in the chat where you're joining from and if you were here last week. And please do take a second to either scan the QR code or I will pop the link in the chat in a moment and register for the session. You will get free learning materials from Microsoft related to the session, and it shows Microsoft that that people are joining in our sessions, are learning from them, because Microsoft kindly sponsor Cloud Lunch and Learn, so it feeds back to Microsoft that we're doing a good job. So
with that feedback, Microsoft will be able to provide more resources, more sponsorship, and so on.
Yes, exactly. So yeah, the more people register and provide this feedback via this form to Microsoft, the better for Cloud Lunch and Learn, and the more we can bring you. On that note as well, before we hand over, I just want to let everyone know that we are in the final stages of getting ready for our global Cloud Lunch and Learn marathon event on May the 13th. We have 170 plus sessions. We've got 5 or 6 languages covered. It's going to be an amazing event. We have got prizes to give away. So yes, please stay tuned to all our socials, because from next Monday, if everything goes well, from next Monday, there'll be loads of excitement and lots of opportunities to get involved, prizes to be won, there's swag kits, there's sticker vouchers. We all love a bit of that. So yeah, please do stay tuned to the Cloud Lunch and Learn socials for next week. And I hope to see you all there and involved. So with that said, I am going to hand over to Ishan and John to kick us off for GitHub CI/CD session.
Hello, guys.
Okay, thanks, Lisa. So let me just pop up the introduction slide. And we'll tell you a bit about ourselves, I guess, just to recap for anyone who wasn't in the session last week. So as a way of a quick introduction to myself, my name is John O'Brien, and I am a cloud solutions architect working within the Western European team in Microsoft's digital sales organization. And I focus in on 2 key areas of Azure: apps and infrastructure. So we're straddling both the app dev side of things and the operations/infrastructure side. And I'm here with my colleague Ishan Jain. Ishan?
So yeah, my name is Ishan, and I am also cloud solution architect. Actually, we are in the same team, me and John, for Western Europe. But my focus is more on the data and AI side of Azure business.
Yes, and I think maybe the difference today, as we kind of set up what we're going to talk about, maybe with the introduction today, I suppose a little bit about my background. So I come from a very much an infrastructure background where I worked in operations teams, various different titles over the years: systems administrator, systems engineer, solutions architect, consultant for operations. So I'm very much about, the guy keeping the lights on, designing systems for resiliency, looking through disaster recovery. So I approach, I suppose, the Azure services and what we're going to talk about today from particularly around GitHub Actions and CI/CD. I approach it from the operations portion of the DevOps formula. And Ishan?
And I come from the app dev side, so application development. I used to be engineer before I came to Microsoft. So I did role as Scrum Master, as solution architect, lead developer, and so on.
So I guess let's say today we have two sides of the coin, right? We've got development background, strong development background from yourself, Ishan, and I would be.
And you come with the operations.
Operations side, yeah.
And that's what DevOps is. Like, it's dev and ops, operations together, development and operations.
Exactly. And a key component of that is what we're going to talk about today, which is CI/CD and using something like GitHub Actions to implement this ethos, I suppose. Great. Okay, thanks for that. So we're just going to do a very quick recap. I guess what we spoke about last session for anybody who joined. It's probably fairly clear in your mind. If not, just a very quick recap for people who are new to joining as well. So on our last session, we talked about, I suppose, the two things that make up GitHub as a platform. We went through Git as a technology. So we spoke about Git as a version control technology. The idea behind Git is that we want to have collaboration between development teams who may be in the same buildings, maybe in separate regions, maybe globally spaced out. Most development teams these days are.
Especially today with work from home environment.
100%. So Git as a version control system allows collaboration, but what it also allows you to do is, I guess, work separately, but then come back together again when you need to merge all the various different changes, maybe features, elements of your code. But a primary concern there as well that we talked about was, I guess, Git and its tracking features, the ability to look back at who made particular changes. And another key element we talked about that I suppose is a little bit more, not unique to Git, but I suppose revolutionary. I don't know, Ishan, your feelings on it, but the concept of branching was a big thing that was introduced.
It has been present since, like, I know I have used it in Subversion, I've used it in Team Foundation, I've used it in Bazaar, something developed by Chronicle, who actually created, is running Ubuntu today. So they created their own. But branching actually took off with the Git flow a bit more. That methodology.
Okay, so we talked about Git. Okay, so the technology that underpins, I guess, what is then GitHub. So GitHub is a platform, probably the easiest way to say it, right? It's not one specific technology. It is a cloud-based version of Git, I think, is in summary, but there's a lot more to it.
It's a collaboration platform.
Exactly.
Where you have one component is Git, the way you push your code, but there's so much more. Like, you can manage your project, so you have project management. You can have community engagement through issues, like if you need help or if you find a bug or so on.
Yeah, so big on collaboration, big on things like we mentioned some of the features last week. We mentioned notifications. We mentioned the ability to raise issues. We also mentioned things like release management. You know, you have the capability for hosting your software versioning on the GitHub platform. You know, other things. But one of the things we mentioned at the time was GitHub Actions. And again, that's going to really be our practical demonstration today that Ishan's going to take us through for what is called CI/CD. So again, we're level set here.
In essence, GitHub is more like Gmail. So it's just a provider for hosting your code, essentially. And then Git is more like the Outlook, the client you're using.
Exactly. Yeah. And let's get on with it. But I think the other part then we want to talk about then, just to kind of, again, level set, make sure we're all on the same page. I suppose, why are we using GitHub Actions in the first place? So we're going to talk a little bit about DevOps. So DevOps, we're both Microsoft employees. We're not in an official capacity necessarily speaking about Microsoft products today, but what we're going to talk about is Microsoft's, you know, how we see DevOps. Okay, so this is our definition. You know, research DevOps, you'll get, I don't know, a couple of dozen definitions of it, but Microsoft sees it as the union of people, process, and products for and that word continuous delivery of value to end users. In a nutshell, what we're doing here is DevOps allows us to do certain things within a life cycle for your software development life cycles. So plan and track changes, the ability to obviously develop and collaborate on development, to build your environments through whatever tooling you want to use, to test those environments, to release, to then deploy into a production environment, operate those environments, and then have a, like most frameworks, to have the ability to monitor and learn from the deployments that you've created. So it's again a life cycle that just continues throughout the process of developing your code and deploying your applications. So that's kind of the Microsoft kind of viewpoint on it. But from a practical perspective, what are we talking about when we talk about DevOps? So first of all, it's not ITIL, it's not an ISO compliancy standard, it's not an open group architecture framework. DevOps is an ethos. So it was developed firstly to give a description of what's an ideal state. It's not a prescriptive, like I said, it's not a framework exactly. It's not a list of rules or ideas. It is a concept first and foremost, but what has grown up around it are certain key areas, certain key there were reasons it was developed in the first place. And one of those reasons was communication, collaboration between the developers, Ishan in this instance, and other IT professionals, operations, myself, and people who are concerned with other things, not necessarily getting features deployed or new code deployed, but are obviously involved in the process of releasing and deploying packages. You want to say something?
For example, like I have developed something and I want to release it. So maybe John has a window in 2 weeks. He cannot do it because he has other work to do. He's not just sitting there to just serve me, my needs. So I have to wait until 2 weeks until I can actually see what's going on. But if we combine DevOps, I get some control. John gets some more time for other stuff.
Exactly. Yeah. So you have the ability to actually deploy. I get my time back where I can do other things like worry about high availability or think about patching my systems or looking at my security environments, etc.
And because of that, the reason I'm able to get more control, I'm able to maintain the quality of the code in a different way.
Exactly. So
instead of waiting for deployment, let's say to staging and then say, so if I can deploy as soon as I am done with a feature, the UAT team can test it, and then we can have much quicker, instead of waiting for 2 weeks, we can actually work for 2 weeks.
Yeah, and also I suppose the thing to mention, and it is a point that we mentioned earlier on, is the ability to have a more agile and lean method of deploying your environments. Okay, so Ishan was mentioning, okay, so he has a little bit more control about how he's able to deploy. Again, as operations, we still have input into that, in terms of the requirements from the security perspective, the repeatable tasks that occur. But the idea behind DevOps, one of the key areas and where we're going to focus in on today is making tasks that were once repetitive and manual, that we'd have to do over and over again every time we wanted to do, like in your example, Ishan, maybe find a release window, package up our software, somehow get that software to the person who needs to actually do the deployment.
Write the deployment instructions, the documentation.
Exactly. Yeah, you have to go through that documentation, make sure you don't interpret it the wrong way, all those kinds of things that were fraught with issues and problems prior. So what we're trying to do here with DevOps, one of the things we're trying to do here is to be able to do this quicker, obviously, to get our go to market quicker, or get our products out the door, or deploy our critical requirements quicker. And we want to take the effort off both parties, both ops and dev, in terms of the manual things that they would have to do. And again, what that naturally does then is it's going to reduce the barriers between siloed teams. So we have the silo of the developers, we have the silo of the operations, and they should never speak or cross-pollinate unless we have a release that we have to actually get the software from the developer and deploy. So it's removing those traditional barriers, making it easier for everybody to deploy code and safer and more efficient, and make sure that we're communicating properly. But again, tool sets, the practices, they've all developed over time. There is no one specific definition, but there are certain things. And what we're going to focus in on today in particular is continuous integration, continuous deployment, specifically using GitHub Actions.
Yeah.
Great. So I guess if we haven't sold DevOps as a concept to you already, on why we're doing these things, or why why this is potentially a $10 billion industry, whatever it is, if not now, in the sometime in the future, it is demonstrably better way of doing things. It's become Microsoft's practice. This is one of the things that we adopted many moons ago. All internal engineering efforts now are done through DevOps practices. We've obviously developed our own software, and we also are obviously heavily involved now with GitHub after the acquisition. But some of the benefits here are it's frequent code deployments, as we mentioned, the ability to remove those repetitive tasks, those manual tasks that were in the way. Even things like just getting code from one place to another was fraught with difficulty. You had to use SFTP or some other methods of packaging up code to get it to a team that was geographically dispersed, as an example. The ability then to
and hope for that the team knows what to do with the code.
Yeah, you wrote the instructions correctly, and that wasn't a previous version, as an example. Also the ability to do your code change and then deploy. So that window just becomes so much smaller that you can just do it over and over again. You can get into a Q&A kind of test cycle a lot quicker. Again, some of the things that you previously would have had to deal with in the past, I should say, would be developers who have access to specific, instances of workstations, because that's where they need to do their testing, and there was scheduling issues or whatever. Having, I guess, pipelines or having agents, having the ability to deploy to infrastructure into the cloud, which is a massive thing here. The ability to just spin up an instance, do your commits, test them out, get feedback on them immediately, and then that reduces things like the failure rate. As you can see there, 7 times lower. Even though we're deploying more, we're deploying faster, we're actually reducing the amount of failure, which I think you would think those two things would actually conflict, but they actually don't conflict. You actually deploy more, but
because you have the
failure.
instant feedback, you're able to rectify the error much faster.
Exactly. Yep. And you can redirect your efforts to resolving things in a quicker fashion. And then obviously, time to recover from something. So even if you go through your whole cycle, you've gone through your testing, you've gone through, things still slip through the cracks, you still have the ability to recover from those incidents, because it's easier to rectify, because the manual processes that were there that you would have had to run through are removed, those barriers to commit your code. So even if it does get to production, it does get into the end user state where issues occur, you still have the capabilities to resolve from those incidents, because again, it's more agile, more slick to deploy your code.
And part of Microsoft's or Azure methodology when we are deploying is using a green-blue deployment. So you always have a previous state ready to switch back to if you notice something major.
Great point. Yep. And even things like the ability to look through changes that were made previously, why those changes were made, and have a full track and trace of the commits that were created, why they were created, who even did those changes as well.
And that's where, as we talked about the pull request last week, that's where it actually becomes more important, because then because you're doing peer reviews, you're actually reviewing the code before it's committed to the test branch or something, master branch or anywhere.
Yep. More eyes on before your code actually goes into the production branch, master branch. Great. Okay, so now we know what DevOps is. We've talked a little bit about GitHub and Git. We've talked about, I guess, why we're doing this in the first place, the reasons why, and kind of what we're going to talk about now is what's supporting, key supporting elements. And really what we're emphasizing today with the demonstration today is the CI and CD portion of it. So when we're talking about continuous integration, if anyone was on the previous call, you just remember back to commit time. So when you actually take your code that you write and you change, you're committing it to your branch. What that's going to do is it's going to kick off effectively a set of actions, things that occur, commands steps. And what will happen then is the build will occur right there and then as you do the code committal, and you're testing then. So you run through your testing, and then effectively you're doing all of this to catch any bugs, right? So prior to any deployments, which is the CD portion of it, you run through a continuous integration cycle where you commit your code, and automatically that kicks off certain things that occur, and it checks the state of your code. Okay, are the features working? Are the elements that we put in, does it work the way we thought? Does it even build in the first place?
So in a complex flow, you will actually have something like unit test, integration tests, functional tests already baked into the process of continuous integration.
Yeah, many times manual things you would have had to run through, like even back to the dark days of running test plans that actually have to go through regression testing for your code. A lot of these things can now be automated and built into the continuous integration cycle.
Perfect.
And then the other part then is really when you're doing your merge, when you're taking what you're happy with, you run through your various QA cycles, and you've now got something you're happy with. This is production ready. We now want to get this to our customers. So we effectively then merge back into our main branch, and that will deploy into production. So traditionally, where operations would have to come in and do software installations onto X amount of servers, what you're actually using here is scriptable deployments, and many instances, really, the real benefits and the real scale of this come into play when we're talking about cloud computing, because we're deploying quite often infrastructure as code, and Ishan's going to show you that when he goes through his demonstration, that this is going to deploy resources. It's there's very little user involvement, and the big thing about this is these repeatable things. We know where all of these steps are in these files. They're going to be in our workflows that we can review and make sure that we're doing it the right way every time. Again, no one has to read it, documents to do it.
Precisely, and because we are freeing up the developers' time and the operations time, you can actually get more done and do more releases, because a lot of time you don't even notice, like you're on a site, it actually updates while you're there. From one page to another, it might even change the full theme. But you didn't notice that because when they did the deployment, because it was all automated.
Yeah. Yeah, 100%. And one other thing I suppose I should have mentioned as well, and we will talk about it later on with GitHub Actions, but when you're doing your continuous integration as an example, we're not like, the awful sensation of realizing that a developer did his testing on his own workstation, has occurred to a lot of people, once they go to deploy to production. So
here we're going to get away from this idea. It works on my station. It works on my laptop. It works on my computer.
Yeah, exactly. So this allows us to have, again, repeatable tasks, but also the ability to deploy to infrastructure that's the same every time. Effectively, our gold state, gold image, whatever way you want to call it. And we're not reliant on specific packages that are installed to one developer's workstation or framework versions or whatever it is that they have installed. Yeah. Anything else to add? Or, well, I suppose we have the continuous learning and monitoring. That is an element here, but we're not going to cover that necessarily today. I mean, we can do future sessions where we look into other areas of GitHub. But today,
if you remember the wheel that John showed in the previous slide, it actually does says that you have to learn from what you did by monitoring the application, because it's not, the cycle is not done just because you have deployed something, because then you have to see how good it's going to perform and then see long-term aspects of it, of this new code.
Absolutely.
And the monitoring and logging and all that comes in.
Yeah. And quite often, I suppose it would have been traditional that it would be the operations team that would actually deal with those elements. They would either get it through support tickets, maybe the first time you hear about an issue occurring. So the idea here is to actually get ahead of the curve here and actually have the developers get immediate feedback on what's been deployed into production. Great. Okay. So on the next slide, I'm just going to briefly, we won't go into it in too much detail because Ishan's going to give the practical demonstration, but just some core concepts to understand about GitHub actions, which is again underpinning all of our CI/CD stuff that we talked about there. So some things to note, we're going to talk about workflows, and what these represent are the procedures that we talked about, the automated procedures. They're made up of jobs, and they can be scheduled or triggered. You want to say something, Sean?
In some other DevOps software, it might be called pipelines. Like in Azure DevOps, we call them pipelines, for instance.
Yep, exactly. I think I even used pipelines earlier on. So the event, as we said, so something occurs, the event occurs. So I suppose maybe the example here would be, easiest one to hang on to would be either a commit or a merge. That's what's going to be coming up in the demo.
It can be like a pushing to a branch, or it can be like creating pull request to the branch.
Pull request,
it can be scheduled. Like if you want to create a nightly build of your latest code, you can do that.
Yep. And that leads me on to a job. So a job is as you can see here, it's a set of steps that execute on the same runner. So runner is a term, I guess. Do you want to take that? Runner is a term.
It's an agent.
For agents, yeah. So it's effectively the infrastructure that it's going to run on, a server, container.
It can be a server, it can be a virtual machine, it can be a container. Usually it's something it's set up just for this particular job and killed off after it's done.
Exactly. And this GitHub has options that you can, quite often it's cloud-based deployments.
Yep.
At the back end of it with GitHub, it's quite often it's Azure, but you do have options, for enterprise deployments if you want to deploy it onto infrastructure that you own, maybe servers, special servers, or something you want to keep it within your organization. You don't want anything.
Or if you have some special need, like some special libraries which cannot be packaged in a certain way, or it has to be, in order to build a package, you need to have some certain libraries, then you might need custom agents. And in Azure, we call them self-hosted agents.
Yep. Even things like operating systems, even when I think about it, so the specific operating systems.
For some reason, you might need to target an older operating system, let's say Windows 7.
Yep.
And you need to build on Windows 7, then that's not available in cloud anymore.
So the next thing then we have is a step. A step is an individual task. So that task is running one or several commands within the job itself. And then the actions, we finally got to the smallest, I suppose, component, as GitHub describe it. So the smallest component of a workflow is an action, and you just think of that as a command, I guess. It's probably the easiest way to think about it. Or commands that are put together to achieve something. So using the Azure CLI as an example.
It can be things like checking out the code. It can be setting up environments in order to create a build. Like it can be like logging to a certain service, or building the software, testing the software, or even before that, you might need to restore your packages. Like if you're using npm or Maven or Nugget, you will need to restore the packages because they are not packaged, you haven't checked in them. So these can be different actions, like restore this project, build it, test it, publish it. So these are 4 actions then.
Yeah. So quite powerful, and again, things that you potentially would have had to do manually yourself. So put it all together, this is how it looks. So our event kicks off our job. We have jobs that can run in parallel or in sequence. They have steps within those jobs which initiate actions effectively. And I think your demonstration has 2 jobs in it, and there's going to be
2 jobs.
One's a CI and one's effectively the CD portion of what we discussed. Great. Okay. And finally, just before we get to the demo portion, just a quick recap. It's probably handy just to do it again, just to say that the GitHub flow, which we've discussed, would include, first of all, creating a branch. Okay, so I have a new feature, I have something I want to deploy, and I want to work on it. I want to make my commits to that. I want to do pull requests and generate code reviews. This is just good practice. As Ishan mentioned, have eyes on the code to review it. Run it through some kind of Q&A where it gets deployed onto a runner, onto container, staging area, yeah, whatever it is. It's some kind of infrastructure. We do our QA,
Or
everything's okay.
it can be a UAT at this point.
Yeah, user, exactly,
to
user
test it.
acceptance test. Yeah. Bring somebody in, get them to test out the features. Nobody knows your software like
So,
people who
like
use
if you're
it, right?
developing something for business, it's better to get somebody, a V team from the business to actually test it. Is it what they actually wanted before it actually hit the production?
Probably a good thing to check. Yep, absolutely. And then we are all successful. So we're going to do our merge and we're going to deploy our code into production state. So that's the GitHub flow. So I suppose where we're sitting within this, I suppose what we're talking about now, it's really all of these actions here, right? All the way from the commit, pull request, code review, Q&A, and then merge tag deploy. CI/CD
it's a continuous integration. The whole thing is continuous integration, and when it do a deploy, it's a more continuous deployment because then you can do multiple deployments a day.
Yep. Okay, with that, I'm going to hand over to you, Sean, to share. And yeah, let's do it. Okay. Stop sharing. Okay, over to you.
Yep. Lisa, can you help me? Thank you. So I'm going to start with where we left off last time. So we created a ASP.NET project, and we just pushed it and did a basic pull request on it. So today we're going to talk about actions. As you can see, I don't have anything. It's telling me to get started, set up flows, and so on. So what I'm going to do, start by, is go into settings and add some secrets. Some of the secrets you can obtain, let me show you, by issuing this command using Azure CLI, which is Azure CLI. We're going to do operation on AD, create a new service principal, and we need to create for RBAC. And then I call it my ISJN GitHub Actions. I want it to be a contributor, and the scope is going to be my subscription. And I need to have it astic out. And it will return, when it's created anew, it will return some secret, subscription ID, tenant ID, and a bunch of other stuff. So I'm going to take that. And for this, you need to be logged into Azure with using the command AZ login. So what I'm going to do,
Ishan, these credentials, then you're going to utilize them within the workflow to do something in Azure. That's correct?
Exactly. So let's create Azure credentials, and I'm going to copy the blob, add secret. Another thing we need to do is we need to get some secrets for registry. So what I did, if we go back here, yep. So I created a new resource group in Azure portal called CLL GitHub. That's what we did last time. And then I created a new registry called CLL GitHub. Adding a registry is simple as click on add, going down to containers, click on create. Let's go back. And if I click here, I can see the registry, it's empty, nothing is used, and I have 10 GB allocated to me. If I go down to access keys, if I click here, when you come here first time, it's going to be disabled. I have enabled it, and it will give you a username and password. So what I'm going to do is copy that and add that as secret. So here's my registry password. And I'm going to add a username. And we're adding this because these are sensitive information. We don't want any sort of security breach. So these are these are saved in a very secure manner. So with that done, I'm going to go back to code. And I'm going to create a new file here. And because with time, GitHub is evolving, you can actually do a lot of things directly here in the portal now. So first of all, for GitHub workflows, we need to create a new folder called GitHub. .github to be more precise. And workflows resides in a folder called workflows. And the workflow can have any name, but it should be a descriptive name. So I'm going to call it main.yaml. And in there, I'm going to paste a code, which I will go through. So I will commit this. I will come back to this file because I want to kick off a build, because that's going to take some time. If we go to actions, now we can see the view has changed, and now it's showing me under workflows that I have one called build and deploy. I can go in here and I can kickstart it.
So Ishan, that workflow, that YAML file that you just created, that includes all the elements we mentioned earlier on. So the various actions, the steps, everything that makes up a workflow.
Precisely.
Yeah.
Let's just take a quick look at this Azure portal. And if you go to CLL GitHub resource group, even if I click on refresh, I only have a single resource. Keep that in mind. It will be relevant soon. So here, let's start from the top. The first thing you should define in your a YAML file for workflows is the name, what you want to call this workflow. So I call it build and deploy because that's what I'm going to do. Then you have what we could talk about events. So either on push, pull request, and workflow dispatch is a very special one, which is for so that I can do a manual trigger. If I don't have this line, I wouldn't be able to do the manual deployment. And then I can specify some constraints, like I only want it to run if it's a push on main branch, and if there is a code change in my site folder. Everything outside will not trigger it, and that's why I had to manually trigger it. Otherwise, if I didn't have this path constraint, it would have triggered the deployment by itself.
And you want to include, that's your include, I suppose you're filtering, right? But there are other reasons why you would do that?
Because you might do things that are not like documentation. You don't want to kick off a build or kick off a deployment just because you update some documentation or you adjusted some configuration file.
Gotcha.
This is just a control so that you don't have too many builds unnecessarily, because every minute costs you. So you get something like 3,000 minutes for free per month, but after that you will have to pay.
So if I was to go into my code and decide I want to change, the first letter of every comment to alphabet, I don't necessarily want to do a build and be charged the luxury of doing that. Yeah.
Precisely. And same thing here, where you're doing, it will only trigger when we do a pull request on top of main branch. If we are doing pull request on other branch, it will not trigger it. And then we come down to something called jobs. As John talked about, it's more jobs are built up of steps. So here in this one, we can give it any name, preferably one word. And then the first thing I like to define is what type of agent or runner I want to use. So in my case, I'm using Ubuntu latest. So it is Ubuntu 2004 LTS version. And then after that, I define all my steps. So first of all, I need to do is check out the code from the repository, because this is a clean container or clean VM, whatever. GitHub is easy. It's a clean environment. It doesn't have anything. And that's for ensure that we don't have something like bleeding effect. So that because of you have to install something for some other project, it's going to result in an error in build of this one. Second thing we are going to do is set up our environment by logging into Azure. We're using Azure CLI to log in, and it's a very simple command, which Microsoft provided under Azure/login. And then we are providing if you remember Azure credentials, the secrets we provided, so this is how we access them. Next thing we need to do is log into our container registry. And that's what we're doing here. And if you remember the password and username, it's already here. And this is the registry. And next thing I'm going to do is actually build the whole thing. And here I'm using what we call the SHA checksum of the commit as my tag, so that each and every time I build, I have a unique tag, because that's one of the unique piece of code we have in GitHub without using any randomizer or any unique generator. And then lastly, I'm going to push it to the registry.
That tag is based on.
Pardon?
The tag that's based on, you mentioned that it's a hash of the commit, is that right?
Yeah. So if we go up here, you see this hash. So that's the hash. Each and every commit gets a hash, and that's what it's going to use, the latest hash of it.
And that's the unique value element you mentioned. Yeah.
And then lastly, we're going to push it to the registry. And then I split into 2 steps, build and deploy. You can do it in one, you can do it in several other, but I like to do each and every individual so that I have more control over things. And that's very important when you are especially using like pull request in Git flow, because you don't want to deploy to production each and every time you do a pull request. So I split into 2, and then the first thing I write is it is dependent on build. So if build fails, the deployment will not run. And it will only run after build. And then again, it's going to run on Ubuntu latest, and very important to constrain if, and I need to know that it's actually running on main branch. I want to run it on any other branch, because then I might be pushing non-production code to production environment. Same thing again, because it's a new job, it's a new environment, we don't have access to it yet. So we log into Azure via Azure CLI, and then we deploy the code to ACI, Azure Container Instance. And here we're defining which resource group. If you remember here, it's the same one, CLL GitHub. We are giving it a DNS name so that it's easy to remember. It needs to be unique for the region. We're telling it with image. If you see these 2 values are same, we're telling it from where the image is stored. Again, here's the same value. And then we're telling how to log into the server, which is also up here. And then we're telling this action what it should be called in Azure portal and which Azure region it should be deployed in. Let's see if we go back to actions, if it actually succeeded. We see now it's a green tick. If you go in there, it built it. And if I go into and deploy and expand this, I can see that it was deployed on this URL. If you go back to the portal and refresh it, we can see now we have a container instance which is called my site. And if I click on this here, I see it's deployed a site which we last time worked on. So next thing I'm going to do is I'm going to make a quick change. So let's say if business have a requirement that they want to change this welcome message to something else. So I will go, in this case, because it's a very minimal change, I will actually do it right here without checking out and doing the whole thing. So I will go to my site. I know which page it is. It's an index page. And I can just click on edit and click here, welcome to my site. And if it would have been set up properly, this option would have been disabled by default. So I'm going to pretend it is. So I'm going to do it in a new branch. And I'm going to call it new welcome message. So descriptive, we know exactly what it is. So I'm going to propose the change. And because I'm already in Azure in GitHub portal, it will take me to help me to open a pull request. And now from here, I can just open a pull request. But before that, I would like to write a little note that I changed the welcome message. Create pull request. And we can see it's going to, it tried to do a merge and it didn't find any conflicts, and it started to build run the workflow we defined. And this is great because there's a workflow it can run. But if I set it properly, put some branch rules, it is actually going to be disabled. And if we go to checks, we can say it's running now. We can see in real time what's happening. And if we go up, we can see each and every step what has happened. It has checked out the code, it has logged into the Azure CLI, and so on. Now it's building the container. So it's going to restore a project, build a project, publish it. And now it's pushing to the registry.
And your criteria for success that you defined here, Ishan, was just to say if the build failed, don't deploy. So effectively what's happening is like GitHub Actions, what you've used in this workflow, it's able to tell. It's not like you had to write something specific to catch an error message or it's just built into the product that it will actually,
precisely,
it will know if there's an error occurring.
Yeah. And here we can see it's a 8619 ECC, the hash code for this. And then if we go back to Azure portal into the registry, and we go to repositories, we have a new repository called MySite. And in there we have to, okay, I have to find out where it's getting the hash from. Wait a second. Yeah, and there it is. The 12E3E61. And if we see here now, that's the latest one here. This is the previous one we built. It pushed it. Now it's the new one. So every time if you're doing the same build, it's going to publish with the same tag, and that's to actually to maintain the continuous, so that we have the same code in GitHub and in our registry when we are doing our continuous integration deployment.
So as an operations person who is in charge of the Azure infrastructure, if you want to track and trace what changes were made that potentially cause service issues, maybe again, if it's occurred, or to track it back, it's very easy to do that because you can actually see the issue that you raised and the pull request you raised, I should say, and the note that you wrote, which is effectively, I changed the welcome message.
Yeah. And now we can see the build part of this was successful and deploy was skipped. And now we can do rebase. And it wants me to confirm. And that's it. And now I can delete the branch. And now if I go back to actions, it kicked off a new run of this workflow automatically. If we go in there, we can see that it's on build step, and then it will go to deploy when it's done with the build this time, because we pushed the code to main now. And this is going to take like maybe 2 minutes, 1 minute for this and 1 minute for deploy.
So it's just while we're waiting. So the rebase and merge, I think you were mentioning there earlier on today, there's multiple ways of actually merging, and we're not going to go into it today, but there are various different concepts around how you would do this?
And there is like a straightforward merge, then there is a squash and merge, then there is a rebase and merge. These are different philosophies how you should maintain your working tree. And it is a very deep, advanced topic, and we could probably run a session on just these three concepts, how to maintain your tree. If there's any interest, we will be happy to have a new session on this. And now we can see that it actually went to the deploy and it's starting to run. And if you come to this screen, you can actually see that what triggered this. As we can see, it's what triggered on push. And again, we can follow it if you want in real time. Now it's deploying the container instance. And because there's already a container there, it's just going to refresh what image is running in that container. So this should take less time than last time. So if we go back here in this one, this thing takes 1 minute. Okay, that's respectable. And we can see here already, like it was 3 minutes total. And if you have, like, sometimes you need to have artifacts, you don't want to push to your registry, you can actually put that as an artifact in the as part of the run. So then it will show up here. Still running. It succeeded. And if we go back, and now we have a green tick, so we know it succeeded. And if we go back to the site and I hit refresh, we can see it changed the title. And that's all I had for demo. There
Great.
are other concepts on how you create how this works. Maybe I should just quickly go through, like, what does this mean? So if I just copy this here, Azure/async, and then paste this here, because Azure is the username or the organization, and async deploy is actually just a repository. If I go there, I can see that here they have a actions.yaml file. That means this is actually action I can use in my project. If I click here, I can see the name of the action, description, inputs. If you remember, we put in resource group, we did put in DNS name, and so on. And we are actually defining things like CPU here. So it will use one CPU by default. We're defining some other aspects of it, and so on, like port, protocol. And we're also telling that it's going to output a URL. And here is the main critical step, what is going to run. So this is going to use a Node version 12 to run a file, a main.js. It's a JavaScript file, and if you go here, back to code, click on library, click on main.js, here we can see the whole code of what it actually is doing in that action. And this is as simple as writing your own code, own actions. GitHub is providing a very good tutorial on the GitHub Learning Lab, and I will highly recommend that.
And for each of, well, not each Azure product, but for a lot of Azure products, we do have document. That's just for ACI. We do have for other Azure services, app services, AKS.
So here is like a link to the repository for the ARM deploy, so you can do infrastructure as a code from directly from GitHub. And there are several things here.
Yeah.
And this is officially maintained by Microsoft.
So I think we can actually maybe drop that in the chat. Yep. Maybe if anyone wants to follow up on it. Great, thanks, Ishan. Yeah, so I think we have 4 minutes left. I don't see any questions in the chat unless there have some have come through. But yeah, so maybe give it a minute or two, Lisa, and if there's no questions, we'll wrap up.
Hey guys, I no, don't see any messages in the chat. But I will drop these links. So if you are still with us, just give me a moment and I will drop these links in the chat. Let me pass those over. Awesome. It's funny, I have access to a GitHub Pro account through my MVP benefits, but as I've said before, I'm not actually a techie. But these sessions have been really good because I've been looking more into this and learning more. And last week I did the Hello World for C#, and I'm going to try and continue with that through March. My plan had been to do a little bit every day, but this week I managed to do some Sunday and Monday. What day is this? Wednesday, Sunday and Monday, and then it stopped. So yeah, I'm hoping to continue with that. But I really appreciate these sessions, guys.
Yeah,
they're really helpful.
My pleasure.
And let me just share this one as well in the chat. Thanks everyone for watching. There's still some people here. Some have jumped off. So we've posted all the links in the chat. If you watch this video back later on YouTube and you think, oh, I missed out on those links, let us know. What I'll probably do is, Ishan, if you could drop me them, or I can take a note of them, but I'll try and get Hugo to add them to the show notes as well, so that people can access them. Yep. Yeah, that'd be awesome. Thanks everyone.
And if you have any questions, you can ping me on LinkedIn or Twitter. I do occasionally use Twitter, not so much, but LinkedIn I'm on every day.
Awesome.
So it's basically, that's if you do linkedin.com/in/BitHunter, you will find me.
Awesome. And I think so I spoke about the fact that next week we're going to start sharing what we've got planned for our global 24-hour event, the Cloud Lunch and Learn Marathon in May. And I think we're going to invite people to join our Slack community so that we can build up a Cloud Lunch and Learners community, and people have an environment where they can feel safe in terms of asking questions, and they'll be able to interact with our speakers and get help there as well. So yeah, definitely watch out for that.
Sounds awesome. And it sounds very exciting.
Yeah. I'm super excited about what we've got planned for the event. I'm so impressed by what the team has managed to do in the background to get everything ready. We've got some amazing, Microsoft have been brilliant, and we've got some great prizes. We're going to have a cloud skills challenge. There's going to be the ability to win certification vouchers. It's going to be awesome. And then I really want to sort of invite everyone into our Slack community and start to build that community of Cloud Lunch and Learners, so that we can help people who are getting started on their cloud journey.
And I will be continuing my IoT series with IoT on Edge talk.
Brilliant. Yes, IoT is a hot topic right now, and one that I'm also interested in learning about. So that's great. Well, thanks,
guys.
You
do have just a quick shout out. Go to the YouTube channel for Cloud Lunch and Learn. We have so much content from previous sessions, which is recorded.
Yeah, so true. Definitely check out the Cloud Lunch and Learn YouTube channel for content. It's becoming a really decent channel full of loads of really great sessions and knowledge. So yeah, I'm proud of how far Cloud Lunch and Learn is coming a year.
I remember, was it just a year ago, me and Hugo were just talking about it.
Yeah, exactly. And actually, shout out to Hugo, by the way. Honestly, let's send Hugo positive vibes, because that man has been working around the clock to organize this event. It's crazy that he needs to go to sleep. I've told him after this event, he needs to take 2 weeks off, and he needs to take a break. But yeah, he's doing a great job. So shout out to Hugo. And thanks everyone for joining and sticking around with us. And yeah, if you've got any questions, just reach out and we will do our best to help you.
Thank you, everyone.
Thank you, guys.
See you later.
Have a pleasant evening. Bye.
Bye.
Bye-bye.